Geo students, welcome to our next video. We're moving on from Pythagorean Theorem, and yeah, we're moving on to applying special right triangles. All right, so there's two types of triangles that we're going to focus on. The first one's right here. You see a picture of it. Excuse me. It's an isosceles right triangle. So let's think about that for a second. Isosceles, we know that means that the side lengths have to be the same. Sorry, the legs have to be the same. Well, we know it's a right triangle. And we know back from chapter 4 that if sides are congruent to each other, well then the angles have to be congruent to each other. So that means that both of these angles have to be 45 and 45. So you're going to hear me saying, instead of isosceles right, more times than not, you're going to hear me saying 45, 45, 90. All right, that's just what I say more times than not. Okay? Well, there are some rules, properties of special right triangles, this one in particular, 45, 45, 90, that will always work. All right? And basically it is in a 45, 45, 90 triangle, the legs are congruent to each other, and the hypotenuse has a length of the leg times square root 2. Okay, leg times square root 2. All right, so this is the very wordy version of the properties of an isosceles right triangle, or 45, 45, 90. What we're going to do here is I'm going to just kind of prove to you why this is always going to be true, and then once we have it proved, well, we can use it forever and ever and ever. So, what we're going to say here, hear me out. So I'm gonna do something right now, and then we're gonna switch it up just a little bit after we make our proof. But to start, I'm gonna say, well, if this is an isosceles right triangle, well then my legs have to be the exact same, and I'm going to call them both x and x. Well, I don't know what the hypotenuse is, but if I have two sides, can't I get the third? Absolutely. So I'm going to say that c squared, because I'm looking for the hypotenuse, is equal to x squared plus x squared, or a squared plus b squared. So if I keep going, I get that c squared is equal to 2x squared, and when I square root both sides, I get that c is equal to, well, the square root of 2 can't simplify, it's just the square root of 2. But the square root of x squared, we've started to talk about this, is just x, right? Square root and square cancel each other out. So c has to equal x square root 2, or whatever the length of the leg was, times square root 2. Oh, I just realized I'm off the page a little bit. Sorry, guys. Hopefully you were able to work through that with me. All right. So, we can always use this pattern. If you want to just use patterns and say, well, if I have the leg, I can multiply by square root 2 to get the hypotenuse, I'm okay with that. One thing that I like to do, and I think is a little easier, is I like to use proportions. And by that I mean, if I set like a dummy triangle, okay, I'm going to draw one more 45, 45, 90 right here. Okay, not the best, but 45, 45, 90. What I'm going to do is I'm going to say, and I can compare every single 45, 45, 90 to the one I'm about to draw. That has a 1 and a 1 for the legs, and well then, if I put 1s in for x here, then this is just 1 root 2, or square root 2. And I do this because now I know, as we move down, we're going to start, I know that if I have a 45, 45, 90 triangle, well then I know the side lengths always have to go 1, 1, square root 2. And the really nice part, guys, is that we're just creating similar triangles. I'm telling you that this triangle right here, excuse me, oh my gosh, This triangle right here, 45, 45, 90, well, it's similar to this 45, 45, 90. And so I can just set up the proportions like we just did in chapter 7. If my leg here is 1 and 1, well then the two legs from this triangle have to go in these ratios. So I would put a 9 here and a y here. And then of course the square root 2 is the hypotenuse in my dummy triangle. So that has to line up or be in proportion with the x. Alright, so now we have this set up. Now we need to actually solve twice, right? We need to get x and y. So the important thing to understand is I cannot use these two ratios. I can't set up this proportion because I have two variables, right? Can't do it. But what I could do is I can use, I can use this 1 over 9 twice. I can say, well, 1 over 9 has to equal 1 over y. I can also say 1 over 9, this over here, has to equal this ratio over here, so square root 2 over x. Now we just cross multiply. Alright, so we get y is equal to 9, and we get x is equal to 9 square root 2. Now, this is an example, and hopefully you see this. Could we have just said that right away? Could I have just said, well, if this leg is 9, well then this leg, which is y, has to be 9. And we learned already that the hypotenuse is just a leg times square root 2. Okay? So what I'm trying to get at here is, like, if you can kind of memorize the rule, that's fine. I'm cool with it. But until then, I would like you to set up proportions, because that's what we just did. We just did all of that in chapter 7. Okay? Okay. Let's move on. Let's do at least maybe 2 more of these, and then we'll move on to our other special right. Excuse me, guys, my bad. Okay, so again, we have a 45, 45, 90, and I always know that that goes from 1 to 1 to root 2. 1, 1, square root 2. And now I kind of just I say, what is corresponding to the 1, and the square root 2 in my dummy triangle, but in my new triangle? And I look, well, x and y are legs. So x and y go under 1s, and 5 square root 2 goes underneath the hypotenuse, or underneath the square root 2. At this point, I would set up, I guess, 2 proportions. You really don't need them, but let's talk through it. Okay, so if I set both of these up, and then I also have 1 over y is equal to square root 2 over 5 square root 2. Alright, I would cross multiply here. So now I have x square root 2, right? X times square root 2 equals 5 square root 2. And I also have y square root 2 equals 5 square root 2. Well, hopefully you agree with me. I would need to divide both sides by square root 2 by square root 2. They would cancel, and I would get, sorry, I'm going to go this way just because I'm running out of room, x equals 5. And I would do the same thing over here, divide by root 2, cancel, y equals 5. Alright, so this should make sense. Both of the legs should be the same, which is great. What I want you to do, and try to understand, is that if we knew the hypotenuse was 5 square root 2, how do you go backwards from the hypotenuse to the leg? Well, if we went from a leg of 9 and multiplied by square root 2 to get the hypotenuse of 9 square root 2, well then we have to do the opposite thing if we have the hypotenuse. We would have to divide by square root 2 to get one of the legs. Alright, so again, the reason I'm talking about that is because we don't always need these proportions if you can kind of think about the rules of how to get from leg to hypotenuse or hypotenuse to leg. Okay? Okay. Let's do one more, and then we'll probably save one to warm up with in class. If we take a look at number 3, be very careful here. I don't tell you that these are 45 degree angles, but if the sides are congruent, right, and I know that because x and x, well then I know the angles have to be congruent. So that tells me that these are both 45s. Alright? So, 45, 45, 90, which means we're going to use our dummy triangle again. This one over here, 1, 1, square root 2, 1, 1, square root 2. And the 1 and the 1, they have to correspond with the x's, right? The legs, x and x. And here is our hypotenuse of 8. Okay, so we set up. Guys, hopefully we agree. We really only need one here. We have one variable, so we don't need to do this twice. We just need to say 1 over x equals square root 2 over 8. 1 over x equals square root 2 over 8. And when we cross multiply, we get x square root 2 equals 8. Now, here, similar to what we just did on the last problem, we need to divide by square root 2. Divide by square root 2. Now, that doesn't cancel nicely in this one. Well, it does on the left side, I should say. So we have x equals 8 over square root 2. Now, if you have a fancy yellow calculator, well then this will give you a nice number. When you do 8 divided by square root 2, it'll give you what you want. For those of you that don't have a nice yellow calculator, and I'm still working on it, I promise, we need to simplify this, and by that I mean we need to get this radical out of the denominator. We cannot have radicals in the denominator. So I need to multiply by itself, because we know that by squaring a radical, it cancels out the radical bar. So if I do square root 2 and then I multiply by another square root 2, well, that's exactly what I want to do. That gives me 8 square root 2, right? 8 times square root 2 all over. Well, what did we say what happens? What happens when we square a square root? We just get what's left what was underneath the square root bar. So we have 8 root 2 over 2, and of course then we can simplify this to 4 square root 2. Alright, we will do more of those in class. Alright, so I think that's good for 45, 45, 90s. Again, if you're not quite grasping this, rewatch it. Try it again. See if you can figure something out that you missed the first time through. But of course, we will be working on it in class. Now for our other special right. I'm going to skip the definition because it's just going to be super wordy. And instead, what I'm going to do is I'm going to kind of work with you guys to prove what's going on here. So we need to continue on this triangle. I just dashed the continuation of this triangle. So now, if I think about my big triangle, hopefully you agree with me. Well, I guess I'm telling you something. My dashed, or my big triangle, is equilateral. Okay? I'm saying that I have an equilateral triangle. And I know that those types of triangles have 60-degree angles in the corners. So when I drop this, or when I cut it in half, what happens to the 60-degree angle up in the top? Well, it gets cut in half as well. So now I have a 30, 60, 90. And that is what our next special triangle is, a 30, 60, 90. So a 30, 60, 90, what I want you to understand, it just comes from half of an equilateral triangle. Alright, so that's important. And then to help us prove the sides, the pattern for the sides, I'm going to set this small side equal to x, kind of like what we did before when I called one of the or both of the legs x. Well, now I'm calling this leg x. Can anyone help me out here? If I cut this triangle in half, the big triangle in half, and just this part was x, well, wouldn't this part be x too? As well, I should say. And so wouldn't the whole side be 2x? It sure would. So if I have a side length of 2x over here, then I know that this side length is also 2x. Now, for the hard part, the last leg. We have to use the Pythagorean Theorem, In this case, I need to say, well, I have the hypotenuse. So I have 2x, and I'm squaring it, right? Because c squared is equal to a squared plus b squared. And I have a squared. Let's call that x. So x squared. Well, I don't have my other leg, so I need to keep that as b squared. Let's see what happens. When I square 2 and x, I get 4x squared. And when I start to move stuff around to solve, I get 3x squared, right? Because I have to subtract x squared from both sides. 3x squared is equal to b squared. And then, of course, when we square root, we should get that b is equal to, well, the square root of 3 we can't do anything with. So I'm going to leave that. But what happens when I square root x squared? I get x. So I know, no matter what, always and forever, that longer leg, the leg across from the 60, is always going to be x square root 3. And so with that in mind, I'm going to again create my new dummy triangle for a 30, 60, 90. And I'm going to plug in numbers that I'm always going to use in my proportions. I'm going to call x 1. So if x, or the short leg, is 1, then the hypotenuse has to be 2 times that, which is 2. And then, of course, if the short leg was x, when I plug 1 into the longer leg, I get 1 square root 3, or just square root 3. Okay? So now I have my triangle that I can use forever and ever and ever whenever I have a 30, 60, 90. And it's going to look very similar to the 45, 45, 90, at least the setup, but the work's going to be different. So now, when I write 30, 60, 90, I don't put 1 square root 2. I put 1 square root 3, 2. Because those are the sides. 1 square root 3, 2. Alright? And now you have to line everything up perfectly. Alright? Notice, I wrote 30 first. So across from the 30 was the 1. In this dummy triangle, across from the 30 in the triangle I'm working with is a 12. So I put the 12 there. Across from the 60 is root 3. So across from the 60 I have to put x. And then lastly, across from the 90 is y. And now I can set up 2 separate proportions to help me solve. So 1 over 12 equals, I'm going to do x first, so square root 3 over x. And then I can also use 1 over 12 is equal to 2 over y. I cross multiply. Gosh, I'm sorry, I'm off the page again. My bad, guys. Let me talk through that again. Again, I can only use the ratio that I have fully, right? I cannot use these two because that would give me 2 variables and I couldn't solve. So that's why I need to use 1 over 12 twice. I need to use 1 over 12 with the middle fraction. I need to use 1 over 12 with the right fraction. And so now I can cross multiply. X equals 12 square root 3. And y, right? 1 times y is y, equals 24. And guys, this is exactly what we wanted. And again, if you're feeling better with like just figuring out patterns, then the pattern is the short leg multiplied by square root 3 to get the other leg, the longer leg. Or the short leg times 2 gets you the hypotenuse. And that's exactly what happened, right? I multiplied 12 by square root 3 to get the longer leg, and I multiplied 12 by 2 to get the hypotenuse. Again, until you feel super confident with those patterns, I would strongly encourage you guys to use the ratios. And so that's what we will do now. At least for one more example, we'll see how we're doing on time. Alright, so again, I have a 30, a 60, a 90. How do I know? Well, if I have a 90 and a 60, then there's no choice but for that to be 30. Let's see here. So this will be 1. Across from 30 is 1. Across from 60 is square root 3. And across from 90 is 2. And these are all going to be proportional because we have similar triangles, right? This triangle is similar to this one. We just did all this. And so now we have to line everything up. Well, we have the hypotenuse, so I have to put that in the right spot. It has to go under the 90. And x is across from 30, so x has to go under the 1. y is across from 60, it has to go under the root 3. I hope that makes sense. Now I set up my proportions. 1 over x equals 2 over 18 root 3. Root 3 over y equals 2 over 18 root 3. And we start to solve. We cross multiply. So we get 2x is equal to 18 root 3, or x is equal to 9 square root 3, right? Because I'd have to divide by 2, divide by 2. So 9 square root 3. And let's see here. 2y equals 18 root 3 root 3, right? When I cross multiply, I get 2 root 3's. Well, we've talked about this now a couple times. Square root 3 times square root 3 is just 3. So I actually have 2y is equal to 18 times 3, or 54. Okay? Lastly, I'd have to divide both sides by 2, and I would get that y is equal to 27. All right. Let's see, how are we doing on time? Oh, yeah, I'm going to stop now. I'm torturing you guys enough. We will do the rest of these problems in class. You know what? Actually, no. I want you guys to try one more on your own before I see you. I want you guys to try, I want you guys to try 8. Okay, I want you to try 8 on your own, and we will probably warm up with 4 and 7 in class. All right? I hope that this is kind of making some sense. Again, there will be lots of time in class to practice and ask questions. Have a good one. Peace.